We're going to be going through, oops, that's the opposite of what my laptop does usually. Do you see this, Meg? We've been signed out probably because of the other laptop. Does that mean it's still recording? Say that again?
It's still recording.
Yeah.
Right?
It looks like it's still recording. It says.
If you click the triple dots, does it still say stop recording? Yeah, okay, it's recording. Let's go with it.
All right. Okay. So you've all been introduced to the command line by now and tried signing in and doing a few commands that you probably already forgot. That's fine. Well, we're going to go through a few. And I'm going to say I'm not expecting anybody to just remember everything and memorize everything the first time. It takes experience, it takes practice for you to just be able to do it out of your head. And that's why we have the cheat sheet next to you there. So first thing we're going to talk about is the structure of a command. The first word in your command is going to be the actual program you're going to run. That's going to be the command itself. So CD in this case is the command. And then whatever follows after space, that's going to be something called your arguments. Okay, there are two types of arguments that go into a command. One of which is an option, and options are usually preceded with a dash. You're either going to have one dash or double dash. A single dash is the shortcut. It's your way of telling the computer the option I'm going to give you is just going to be a single letter. It's not going to be more than a single letter. But when you have double dashes, that means I'm going to give you the actual name of the option, in this case, help. It's the same thing, -h versus --help in most commands. I think one of the most important things we have in the Linux system is the file system. How do you navigate the file system? How do you know where you are? How do you find files? All of that information. And I think chart we have. Okay, so there's something called the root directory on every Linux system. The root directory will be the slash. There's nothing before the slash. There's actually a normal directory in your system. There's nothing before. When you are at slash, that means you're at the very root of your system. After that, you can have files and folders or anything you usually do. So right under that in our system, we have plus. Right? And then after that, there are a few directories, but then eventually you get to the directory that you want of your user. Now, when you see it like this, it's simple. We have 1, 2, 3. Right? The steps are very clear from top to bottom. In the system, the way we represent that is we separate them with a slash. So we start from a slash. This is the actual representation of it. To get to this file, we're going to slash and then cluster. And then to get to the file here, we're going to slash, cluster, slash. So basically what we're doing is just giving it the entire path to where your file goes. Normally, you would just open up the desktop, click into a folder, from a folder to the next folder, so on and so forth. So for the command line, instead of clicking, basically we're going to add slash. Now there are two types of navigating in the Linux system. You have something called absolute path, and that's when you write it starting from slash up until the entire path. And then there is navigating from your current directory, which is relative path, it's called. So if you are currently in cluster, and you want to go to username, you don't have to write the entire path. the system knows where you are, and therefore you can just do cd user. And that will take you to the username without having to write slash Luster slash. Nope, because slash has a meaning. Whenever you start with slash, that means you are doing absolute path. It's going to give you from the very beginning of the system up until the end. If you do not add slash at the beginning, that's telling your computer I'm going to do it relative. See where I am, and then continue from there. Okay? And there are two special symbols in Linux, and that would be the dot and the dot dot. We do cd dot. That means stay in the current directory. Dot is always referring, single dot, always refers to your current directory. And there's dot dot, and you can see the dot dot, that means go back one step. So if I am in username in this directory, when I do cd dot dot, that'll take me a step back less. All right? Even with those, you can add slashes. So you can do dot dot slash dot dot. That means go back 2 steps. We're starting from here, we're going to end up here. If you're starting at the very top and you try to go even further back, so you can tell you how long I want to go. Doesn't exist. Okay? So absolute path and relative path. Most of your programs will probably use absolute path because when a program runs from somewhere, doesn't necessarily have to be more direct to your head. So it doesn't know what this refers to. It doesn't know where it is. When you give it the entire path, it will know where to go. So in your commands, I recommend that you always use absolute path. Now, knowing where you are, let's pull up the terminal. And I'm going to have you all sign in to the ACF, which will be SSH, your username at acf-login.next.utk.edu. Is everybody able to log in? All right. So I created a folder that I need you to copy to your home directory or to your course directory, which is located in cd/Luster Haven courses EPP 531-2019 SU. Use tabs if you don't want to type the entire thing. Okay. It's not allowing my account to access the course directory. Charlie, can I use your account instead?
Did you add the
Project?
Yeah.
Is that different than what we usually have?
No, but because you didn't queue sub, it has you as your default project. Your default project is probably not the one. You essentially have to queue sub.
Okay, let's try queue sub.
You do queue sub, and you have the URL number of the project. The project has existed for a long time. Hello, ACF. We love you. I definitely have a love-hate relationship with this system.
You are not authorized to change project. Odd.
Oh, okay, you're not a member of the project.
Okay, so Charlie.
I can log in.
Let's log in real quick. Oh, there
think the biggest problem that you see is the staff. They've got too many users for not enough employees. So poor Nick. I feel like I'm about to.
Okay, let me try again. Fluster, Haven, courses, APP. There we go. All right, you should have your username here. So navigate to your username. And we're going to run this command. This is a command that will copy a directory to your current directory. So we're going to do cp space -r space /Linux tutorial. And if a slash shows up at the end, remove that. And then add space and dot. Okay? So now you should have a folder called Linux tutorial. If you type ls, it should show you that. Everyone good? All right, let's go into Linux tutorial, cd Linux tutorial. You should see files in there. Okay, so first thing we want to know is where we are in terms of the path. And the command to do that is print working directory, pwd. And that will show you from the root, starting from the slash, up until where you are currently. And that is, you're going to need that a lot to identify exactly where you are, where your files are. When you try to give your files to a separate command, you will run pwd to know where you are. Okay. And then we have the ls command, which is a command to list everything in this directory. The ls also takes options, just like any other command. And you can do -lh. And in this case, what the L does, it just tells ls to give you more information rather than simply the file name. I want more information about the file. And H is for human readable format. Okay? When we run that, it's going to give us a few things: permissions, the user, the group, and then the size of the file. This is, if it doesn't have, what do you call it? A unit, it's going to be bytes. So this is 250 bytes, and this is 4 kilobytes, so on and so forth. And that date at the end is simply when was the file last modified. Okay, so pwd and ls and cd are probably, you're going to use those commands the most. And that's all to navigate the file system. Okay, you're already in your Linux tutorial, so I'm going to skip that. Now, I don't know if we talked about tab complete. You're familiar with tab complete? When you start typing, if I do /lu, cd/lu, and then hit tab, it will know what file I'm referring to because I gave it lu, and there's no other file there that begins with lu. So it will autocomplete for you. And the same thing for Haven. I'll type H and tab, courses C and tab, so on and so forth. If you don't know what files exist, like you reached all the way up to courses, and then you forgot what's next, what should I do? You can tab, double tap, and it will automatically print the rest of the contents of that directory. So you'll be able to navigate further. So when I put type in E and tab, and I got to where I want it to be. So tab is your friend. It prevents you from doing mistakes, and it will make your job a lot faster. Next, we'll talk about creating a directory. We already copied a directory here, so you don't have to run the command that's in the tutorial. But in order for you to create a directory, let's do this. Let's make dir and call it temp for temporary. mkdir, which stands for make dir, and then type a name, whatever name you want for that dir, and hit enter. And now when you do ls, it should exist. And it's a directory that you can navigate to and out from. If I try to find the regular file and do cd with it, like here, there's a file called genecounts.txt. If I do cd into gene counts, it won't let me even autocomplete because it knows this is not a directory. So I hit enter and it says it's not a directory. It's not going to let you go into anything that is not a directory. Okay, you can tell me how would you navigate into the temp directory? cd space temp. Okay, how would you navigate out from the temp directory? Correct. That's it. That's how you go into a directory and back out of a directory. The next command is copy. I already showed you how copy does when we copied the Linux directory to here. So we're going to do it again with the gene counts. And here's the, I think the command is here. Yeah, but this time we're going to give it the absolute path. Okay, so CP, we'll start with / Luster, Haven, courses, EPP, and then your username and gene counts. It's a Linux tutorial, then gene counts. You got as far as that? And here's the important bit. The second argument is going to be the name you want to copy it to. So we can say gene counts underscore copy.txt, or name it whatever you'd like to name it. The second argument, which comes immediately after the first space, right? You have the first argument. This is the command. This is the first argument of the gene counts. And the second argument is the copy. Is the copied file name. If I hit enter and then ls, I should have an exact copy of the file that we gave it. This is one way to copy a file, by giving it the entire path. But we can use relative paths to copy the same file, and I'll do that again without giving it the entire path, because I know it's here. I did ls, I can see it in front of me, so I can do cp genecounts.txt into copy2.txt. And that will do it. I'll also have a second copy in this current directory, and I didn't have to type the entire path because I know where I am. Now, copying directories. If you notice, when we copied a single file, the gene counts, we didn't have any options, nothing with dashes there. It was 2 arguments. That's all we gave it. If I tried to do that to a directory, I have a directory here that we created called temp, and I want to copy it to temp2. It won't let me. So this is a directory, you can't copy it. The only way to do a copy for a directory is to give it a second, is to give it an option. After CP, you're going to do -R. -R stands for recursive, and that means don't only copy the file, but copy everything within that file. So you have a temp directory, anything that's in it also should be copied. When you say that something is working recursively, that means it's going to go down the list up until the smallest or the most inner file and copy that outwards. That's why it's called recursive. You don't have to understand how it works exactly, but know that in most commands, -R means I'm going to deal with a directory now. Okay? So if I copy that, it will copy it for me, and I have temp and temp2. Any questions so far? So the same way we copied a file, we can move a file. And let's see, for example, one of my copies, I can use the command mv to move and give it the first argument as the source file or the file you want to move. And in this case, I'm going to move my copy file, gene counts copy. And I'm going to put it one directory back. I'm going to move it from the current directory, which is Linux tutorial, and I'm going to put it in my username directory. Okay? Hit enter. You do ls, it no longer exists, but if you do ls ... which is the directory just before this one, you'll have the copy there. Any questions about the ... Okay. All right, now we're moving a file. We have the same restriction when you move a file or remove a file or copy a file. They all need to know whether what you're moving is a directory or a regular file. So I'm going to delete this file here that I have called copy2. And the way to do that is rm, and then you give it the name of the file you want. In this case, it's copy2.txt. Hit enter, and it's gone. Now here's the thing. There's no such thing as a trash bin. When it's gone, bye-bye. It's gone. It's not coming back. So you got to be really, really careful with this command. In order to delete a directory, just like copy and move, you're going to do rm-r, and then we're going to delete our temporary directory. And there we go. It's gone. Okay. So now we got through all of the file system navigation stuff. We're going to move on to how to view files and how to manipulate files. Okay. So we've seen this command before. Cat, which stands for concatenate. And that just means that I'm going to print the file on your screen. Okay? Cat, gene counts, and it's going to print for me all the contents of that file. Simple enough. There's another way of seeing the contents of a file. And we also saw that command today, but probably was too brief to really explore. And it's called Nano. Nano is a file editor, just like Microsoft Word is a file editor, just like your whatever Windows has for text editors. What is it called? Notes? What does Windows have for a default text editor?
Oh, I think it's that with a shell, isn't it?
No, I mean like the actual Windows system.
Text edit?
Text edit? I don't know what it's called. Okay, so we're going to use Nano to open a file. Nano, space, and then the name of the file. I'll stay with gene counts. And this is what you see. At the very top, you're going to see the name of your file with the name of the editor and the version of it. And then in between, you're going to see, or in the middle section, you're going to see the content of your file. Now, don't try to use your mouse. It's not going to work. If I click anywhere, it doesn't do anything. You have to use the keyboard to navigate the file. You can change the contents of the file just like you do with a regular editor. Type anything you want, anywhere. Delete. It's like normal. Now, to save the file or exit this or do anything, at the very bottom here, this section is all the commands you can give it. And it's interactive. As you click anything, it's going to show you something else. It's going to show you, it's going to ask you what the name of the file should be, or if you really want to save, and all of that. All interactions are going to happen at the bottom here. This little character means control. That little arrow up, that means the control key. So Control X would be to exit, Control O would be to write out, which is just another way of saying save. So to save this file, we made some changes. We want to save our file. We're going to do Control O for write out. And then it prompted me. Did you want to rename the file? Do you want to save in the same file? You hit enter, and that's it. It says wrote 20 lines. That's how many lines is saved. So to exit, you're simply going to do Control X. Did everyone get that? Okay. That was how to edit a file. Some files are very, very large. You're going to see, especially with genomics data, you're going to have files that hundreds of gigabytes. And that's not easy to edit with a regular editor like that. And sometimes you just want to see a little part of the file without having it take over your terminal with text. So what you do is there are two commands. First of which is head, and that will show you the very top of the file. If I do head gene counts, it's going to show me the first 10 lines of the file. Or I can tell it exactly how many lines I want by giving it the option N, and then specifying the lines. So number of lines is 15, and the name of the file is gene counts. And that showed me the first 15 lines in the file. Second command is the opposite of head. To show you the bottom of the file would be tail. Use tail, gene counts, and I'll show you the end of the file instead of the top of it. It works exactly as the same way as head. So it also can take an argument or an option called -n, and you specify the number of lines, and I want only 2 lines from the bottom, and that will show me the last 2 lines in the file. Okay, you should have files here called Mary, and then points, point 1, part 1, part 2, part 3. Sometimes you don't exactly know the name of the file. You want to find a specific file. You know a portion of it, but you don't know the entire name. Now, the Linux system does not allow you to open a file unless you know its entire name. But there's one way to search for things. Or there are multiple ways to search, but this is one way of doing it. To find a file, you'll just use the command find, and then you give it where do you want to search. In this case, I want to search in the current directory, which means simply dot. That's where I'm going to start my search, and then I'm going to give it a pattern. Say the name of my file, and I know the name of my file here is called mary.pt1. I hit enter. It's going to show me that I found it in the current directory where I'm currently at. That's why it says /, and then mary.pt1. But what if I wanted to find a file, any file that contains the word Mary? I would simply say Mary with an asterisk. Asterisk is a wild card. That means I don't care how many or what characters you have here. I know that it begins with the word Mary. I don't care what it ends with. Find me all of these files that begin with the word Mary. I hit enter, and sure enough, it shows me all 3 files that begin with the word Mary. Now, what if I wanted to search for an extension? The same way, what I would do is just give it the extension. I want all files, asterisk dot, all files that end or have the extension of txt. Hit enter, and it's going to find all files in the current directory and subdirectories that have the extension txt. There's one more thing, and it is contains. What if I know, I don't care what precedes the name of the file, and I don't care what ends with the file. I don't know the extension. I don't know if it has anything else all I know that it has the word sample. So I could say between two asterisks, the word sample. I want any file that has the word sample in it. And it's going to find it for me. So the asterisk is an extremely powerful character that you're going to use a lot. And frankly, I've never used any of the other. There are other characters that allow you to do searches, a little more complicated searches, like contains exactly one letter at the end, or it will be a number at the end, but I don't know what is the number, so on and so forth. And I think the asterisk will be just perfectly helpful and enough for you. The next command here is grep. In your samples directory, if I cd into samples, you're going to see that there are two sample files, sample A and sample B. Let's take a look at these files. Sample A, okay, printed. Has the word leaf and sample B. This little echo at the end is just to say print a new line after you print the content of the file, because it was printing it a little weird, not visible. Anyway, so sample A contains the word leaf and sample B contains the word tissue. And what if I wanted to search the content of these files? I want to know if this, imagine this is an extremely large file and I want to find a single word in it. I want to know if it exists or not. And what we're going to use is a command called grep, G-R-E-P. And then we're going to give it the word we're looking for. In this case, leaf. And it doesn't matter if you give it single quotation mark or a double quotation mark, it'll work either way. In the file name, well, yes, in grep, yes. You can tell it to ignore case sensitivity, but we'll get to that. I'll show you in a second. So you give it the word you want to search for, and then you give it the name of the file, which in this case I want sample A. There you go. It printed it out as red because it found it. If I try to search for the same word in file B, it's not going to find anything, so it's just going to exit with nothing to see. Now, there is an option to allow you to look for a word case insensitive. That would be -I. -I just tells it case insensitive. That will find it. If I remove the -I but don't give it the exact same case I'm looking for, it's not going to find it. Now, what if I wanted to search all the files that I have in this directory? I have two files, and I want to know which file has the word tissue. So I'll do grep, give it the word, and then just do an asterisk. What this does is going to search the current directory for all the files and search them. You hit enter, and it tells you exactly what file has the word tissue. It's going to ignore the rest. Whatever does not contain the file is not going to be in the output of this command. So now I know that the file sample B has the word tissue. The same way with -I, just means ignore case, and it's going to find it. Now, what if I'm out here? Okay, cd ... to go step back. And now I want to search all of these files, and not only all of these files, but everything in the directories within this file. So sample A and sample B files are under samples. They're not currently here. So when I do the same command that I ran before, grep -I tissue, and give it an asterisk. It's not, it just complains. It tells you samples is a directory, temp2 is a directory. I can't search those. I don't know how to search those. And so to tell it that I also care about the contents of the directories, the same recursive option, -r. So you can give it -ir, which means I don't care about the case, and I want you to search directories for me. You do that, you hit enter, and it's going to find from the current path all the files that contain the word tissue. And in this case, it's in samples, sample B. Cool? If you have questions, stop me at any point. It's fine. Okay. I don't know if I want to get into std in and std out, but do you think it's important, Meg?
What?
Std in, std out, std er.
No, as long as you have a greater than for redirected file.
Okay, piping and redirection. Okay. All right. Sounds good. So remember the word cat, which meant concatenate. When I type cat, the name of the file, and enter, prints the entire file for me. That's not necessarily what I want all the time. I might want the content or whatever the command outputs, I want it to go into a different file. And let's call this, since it's going to be technically the exact same file, I'm going to put it into genecopy.txt. This greater than sign, that means instead of printing it for me to see it now, redirect that output, print it into this new file called genecopy.txt. Okay? If I hit enter and then ls, you're going to see that it created a new file, called it genecopy, just like I told it to. And if I look at the content of the file using nano, genecopy, you're going to see that it's an identical copy of the other file that I used cat with. Now, right now, this might not seem very significant. Why would I just copy something like that? So we have Mary part 1, part 2, and part 3, and that's just, I think he called it poem. Mary had a little lamb. If I use nano to look at Mary part 1, you're going to see that it's just the first verse. Control X, and then nano part 2, it's verse 2, so on and so forth. Part 3 is the third verse, okay? And what if I wanted to combine all of these files into a single file? We're going to use a combination of what we used to do something pretty powerful and much easier than using the mouse. This is where the terminal shines. I'm going to do cat, and then I'm going to use Mary, because I know it begins with Mary.pt, and I notice that the only difference is 1, 2, 3. So I'm going to tell it I don't care what comes after PT. You autofill for me, whatever you find, using the wildcard character. And then I'm going to want you to put it into maryrhyme.txt. If I run this command, what happens is if I open the new file that it created for me, maryrhyme, you're going to see that all 3 verses have been combined into a single file. Does everyone understand why it combined all 3 files? No? Okay. So here's what we did. We used the wildcard character. We have 3 files, Mary part 1, part 2, and part 3. Right? We wrote all the way Mary.pt. But then I told it I don't really know what care, actually, what character that comes out. So if there is a character, include it. I want that file. As long as it begins with all of this, which means all the 3 files. If any of these files begins with something other than Mary, like std or gene counts, all of those don't begin with Mary. So they're not included in this expression. It has to begin with Mary.pt, and then it follows with whatever. I don't care what it follows. And then I use the redirect character, which is the greater than sign, to say instead of printing it here or me on the screen, instead put it in a file. I'll look at it later. Put it in a file. And it did. Created, we did ls, the file showed up, mirror.txt, because we named it mirror.txt. Now, if I open it, you'll see that it's all 3 files in a single file.
In your example, you got after the redirect, which I've also referred to as type redirect. I use it for the head command, so I'm going to head minus m, only I won't show the screen.
Correct. You can do this with any command. Any command that.
Totally the power of command line, learning what each of these little pieces do, and then recombining them in every possible way. You know, whatever you're trying to do. And like each one puts a little tiny tool. You can put them together in order. That's what makes command line.
So you referred to piping. Piping and redirection are 2 different things. So we'll get to the piping next. Now, this command, what we did here, if I run it again, it's going to overwrite the file that I created previously. I'm not going to append to it. It's not going to add the content again to the bottom. It's going to completely erase it and create new content, whatever command I give it. So whenever you use this character, you might want to make sure that you're not putting it into a file that you want. Because if that file matches, it's going to be erased completely, and there's no way to recover it. There is another way to redirect. And this particular way instructs it to append. Do not erase the content of the file. I want you to add more to this file. I'm giving you more information to append to the end of this file, and that's simply by giving it 2 greater than signs. If I do double greater than signs and hit enter, and then open the file or take a look at the file Mary Rhyme, you're going to see that it doubled. The content that was there before, and then the new content that I gave it on top of that. It appended the content to the end. Some commands require that you give it content. And sometimes the content is so many lines that you have the input as a file. And the way to do that, so this is a command. Cat is a command. And I'm going to tell it the content that I want you to read comes from this particular file. It's just the opposite direction. Less than sign. So the content, the name of the file that I'm going to give you is your input. It's called the input file. So I gave it Mary, let's say PT1, and it's going to print Mary PT1. Same thing with head. So PT1, it's going to take the first 10 lines, so on and so forth. So I wrote a little program. Its job is to take all the lines in a file and convert them to capital letters. And it's called upper.py. This is a Python program. If I run this program, Python upper, and then give it a file, it's less than sign. Let's say Mary.pt1. Took the file, took every line, made it into capitalized words, and then printed it back out. There is no other way that you can feed this program a file. It doesn't know, it just hangs. It only knows that you have to give me the content. Same thing with cat. If you use cat without a file name, what happens is it looks like it's gonna It's hanging. But it's not really hanging. It's waiting for input from you. If I say, this is me, enter, it echoed immediately what I told it, because its job is to simply print out everything that it reads. Oh, sorry, Control C. Control C is very important. If you see that it's hanging, or all of a sudden you're printing 160 gigabytes file and you want it to stop, Control C. Keep hitting it until it stops. Okay. Now, piping. It's different than redirecting. Redirecting takes your output or takes input from you. Either takes your output and prints it into a file, or takes input from you and gives it to the command, right? But all of these, there's a common word there, and it's file. A file must exist in order to either redirect to it or to take data from it. Now, piping, on the other hand, allows you to combine two commands together. Let's say cat and this upper Python command that we created. So let's take a look what this happens. First command, catMary.pt1. We know what that's going to do. It's going to print the content of the file, correct? Now I want to tell it, don't only print it, but take whatever this command created and then give it to the next command to execute even more operations on it. And in this case, the command is python upper.py. And so what happened is that two separate commands got executed, each one feeding its input from the command before it. Let's do that again with head -n1, and that will give me only the first line. This is really important. The piping is one of the most powerful tools you're going to see in the command line. Let's do this. Let's do one more example. I want Mary and then Python upper, and then on top of that, I want it sorted. I want all of the content of that file to be sorted in alphabetical order. I'll give it sort, and there you go. It sorted it for me, depending on the first letter of every line. On top of all of that, so you executed your list of commands all the way up to sort. You can say, after you're done executing all of these commands on my input, I want you to print it out to a new file. It's redirecting input into a file. Now, if I open the sorted file, you're going to see that it is exactly what you expect. It's uppercase, it's sorted, and it's put into a file called sorted.txt. So remember how we combined all the Mary parts? We can do this again and make sure that it is all uppercase. So cat Mary PT, and then we're going to do the wildcard character, which is just an asterisk, which means get me all the files that begin with Mary.pt, and then make them capitalized. And then after all of that, call it marySorted.txt. What do you expect this command is going to output? Say that again? Eventually, the final output is going to go to marySorted.txt. Does anyone know what this command would output?
Greater than always goes. One is program to program. The other one, the greater than program to process.
So you can't give it, if you use the pipe and you give it a name of the file, it's just not going to do anything to it. It will complain, tell you command not found. It's looking for a command. Yeah. Okay, so the first part, cat, Mary, PT, asterisk. What does this do? Everything that begins with Mary.pt. It's going to grab it and it's going to print it. Correct. It's not going to climb. It has to be within this current directory only because it's not recursive. And then the second part, after the pipe, it's going to take the output of that command, so the combined 3 files, and it's going to make them capitalized. And then eventually it's going to print it to this Mary sorted file. So if I hit enter and then open this new file that was created for me, exactly what I expect. We combined the files, all 3 into one, we made them uppercase, and then we printed them into a new file. Transferring files. I don't have access to Globus, the tool that Nick showed you today, but I think the best way to transfer files in a Linux system, especially if your files are not in hundreds of gigabytes, even if it's 2 or 3 gigabytes, it's fine, is to use one of 2 ways. You can either use something called FileZilla. This is a graphical tool. You don't have to use the command line for it. You're just going to enter a few parameters, and probably wherever you're transferring into would give you, all the information you need, which is the host, your username, password, that kind of stuff. But you have to download an app on your computer to be able to use it. If you are transferring, say, from the ACF to another computing facility, you can't use FileZilla. There's no access. You have to have the file on your system. That's why it's not ideal to learn FileZilla, in my opinion. I think the best way to use this, or to transfer files, is to use something called secure copy. And this is basically a combination of 2 commands that you used already several times. First of which is your SSH command, which allows you to enter into another computer. And then the second command is the copy. CP. So secure copy. That's what this stands for. And we're going to attempt to copy a file from your ACF to your current computer. Okay? I'm going to exit so that I'm on my computer now. I'm going to do PWD to show where I am. If you have Windows, it should say something that starts with a C colon. Is that what you guys say? If you type, yes. Or your home directory, I don't know which one. So is that what you see when you get PWD? Can you share with me what you see when you put PWD? Okay, let's exit. Exit into your own computer. So just type the word exit and hit enter. And then type PWD.
Yeah. So you're trying to get them to the desktop?
Yes, so that they can see the file.
I think she's at /c/user/Allison. This is
So,
the dash, right? So it's mapping it onto the file.
right. So
it should just be CD desktop.
So it should be, yeah, CD desktop. Exactly. CD
capital
space.
D desktop. Just like that, I think will work for you.
Okay, great. Thank you. All right. Now we're in the desktop. If you do PWD, the last word should be desktop. And now we're going to attempt to. Are you good? Your desktop? Okay.
Now CD.
Okay.
I think you're already on that.
So there's the command we're going to use. It's going to be SCP, which stands for secure copy. And then you're going to give it the absolute path to where your file lives. So normally, when you try to log in, you're going to give it your username at acf-login, the entire path, right? So let's do that. Give it your username at acf-login.nix.utk.edu. And here's where it's a little different.
You're gonna have to exit out.
Yes.
Yeah, you're fine. Sorry.
1 second. Let me finish the path and then you can change the username. Okay. So, and then you're going to do calling. Okay. And now this is where you're going to give it the path. You do slash and it's Luster. Notice here there's no autocomplete. Usually what I do is I have two terminals open so I can just copy from one and put it into the other. So if you don't remember that, you can do this. But in this case, I know the path and I know it's Luster, Haven, courses, EPP. What's the course number? 531 2019. Okay. Yes. And
They
it's
never do the short project.
So, and then your username, whatever your username is. In my case, it's this. And then it's going to be Linux tutorial. Finally, that's like the longest path ever. Finally, it's genecounts.txt, which is the file you want to copy. At the very end here, you're going to do dot. Can someone tell me what that means? What the dot means? Oh, come on, you know this. A single dot. Say that again. Yes, the go to dot, the current directory. Don't go anywhere because the SCP or CP commands, both of them take two arguments: a source file, a file that you want to copy, and then the destination where you want to copy it to. If I don't tell it where, it's going to complain and tell you you're missing an argument. I don't know what I'm doing here. So if you do dot, that means just copy that exact same file, that file to the current directory, wherever I am. And I know that I am in my desktop. If I do dot, Jolly, please come put in your so long distance. There we are. Enter. So it should, if you hit enter, it should ask you for your password. Exactly like you're logging into the regular ACF system. And then you'll see something like a progress bar. Because this is a very small file, it doesn't show an entire progress bar. But if it's a large file, it's going to be there's going to be a progress bar. You're going to see the speed of download, how much time it took to download, all of that information will show up. Now, if I do ls, there's a lot of stuff here, but I know that it's here. There it is, gene counts. You should have it. Now, if I go to the desktop, what did it say? Let's take a look.
We're gonna go to the probably around about all over again. Mark. Will not be a problem. Okay, good.
some people were using height, which doesn't